ladies and gents. This is week number 7. Okay, week number 7, a short week. And before I forget, okay, it's in my mind now. Sorry to start like that, but we are going to do a task, not this week, okay, next week. So in week number 8, I will give you a little task to do. Okay, this week we're going to finish our first unit within calculus, which is functions. And yeah, when we finish that, I want to do a little short task. It's just going to be 20, 30 marks maximum. So that will be in week 8. Okay, so probably the first week of June. That's going to be the first week of June. Okay, right. What are we going to do today? Today we're going to do inverse function. Okay, a really, really important concept. You do it in maths. I can't remember. I think you do it in grade 11. Yeah, I think you do it in grade 11, so you might have already come across that, and if not, you will come across that sometime this year. Now, remember, function. What is a function? A function is a set of rules, or is a rule that takes you from one set of numbers to the other, okay? When I explain that to grade 8, grade 9, I call it a machine, okay? A machine that churns number. You put a bunch of numbers, and it takes them to another number. Like a machine. Yeah? Now we're going to come across another concept called one-to-one function. Okay, one-to-one. What is a one-to-one function? Okay, let's have a look at this function. Each number, let's just give it some number. Let's say it takes a 1 and it turns into 2. It takes a 2 and it turns it into 1. It takes a 3 and it turns into 10. Okay, each element. Okay, in the, what do we call it? Domain. Okay, this is the domain and this is the range. Okay? Each element in a domain becomes a different number in the range. That means that you can see that each number in the range, each one of the y values, okay, there's only one x that brings it to it. So 1 will bring it to. There's not going to be another number where if you do the function it will become 2. Okay, that's called one-to-one function. 1-to-1. Okay, kind of say name makes sense. 1-to-1. It takes one x and give it only one y. Okay, let's give an example. Okay, it could be f of x equal x. Okay, that's the simplest one I can think of. Okay, so f of 3 is 2. F of 3 is 3. F of 5 is 5. F of minus 10 is minus 10. Obviously, maybe I shouldn't write it down here because this is obviously not f of x equal x, but f of x equal x is a one-to-one function. Now you might think, hey, not all functions are the same like that. No, of course not. Okay, so let's just think about an example. F of x equal x squared. Okay, so if you put f of 1 is going to be 1, but if you put f minus 1, okay, that's also the answer going to be 1. So pictorially, what does it look like? Okay, you can have two values of x, okay, that eventually assign the same y. The machine gives them the same y value. Okay, that's not one-to-one. That is one-to-one. This is not one-to-one. Are we all right with that? Okay. So the rest of this video, we're only dealing with one-to-one. Okay, pause you here. Okay, so we're just looking now at one-to-one function. Let's say we have an example of that. Okay, so we've got a domain, we've got a range, and this function, we'll call it f of x, assign for each x a unique value of y. So let's say 1, it takes 1, and then it turns it into 3. Okay, let's say it takes 2, and it turns it into minus 2. Okay, right, but there's just one. For each value of x, there's only one value of y. Now, if that is the case, one-to-one function, what we can ask ourselves, is there maybe a function which does everything in reverse? In other words, a function that, let's say, take a 3 and turns it into 1. Okay? A function that takes minus 2 and turns it into 2. So it takes any one of these y value in the range and turns it into the original x value. Now the answer is yes. If it is one-to-one, only one-to-one, I'll write down 1 to 1. If f is 1 to 1, okay, f is 1 to 1, then there is a function that does everything in reverse, and that's called the inverse function. Okay? Right? The inverse function. Okay? And we write, okay, I'll just write inverse. Okay? And the symbol for the inverse function is basically f minus 1. So if this is the normal function f, the inverse function, the one that takes 3 and turns it into 1, will be f minus 1x. Okay? Right now, I don't know what is f. We're going to look at the examples in a minute. F can be anything. But if there is such an f, which is 1 to 1, then there is an inverse function which we do not donate. As a symbol for it will be f minus 1x. Now, it's important to understand that f minus 1 doesn't mean f to the power of minus 1. It's not, that's not necessarily the case. It's f minus 1, just the inverse of this, okay? Sometimes it actually is the power minus 1, but sometimes it's not. I know things are a little bit hazy. Let's make some examples, okay? So I'll use my professor friend, okay? Have you met Professor Pupik? I can't remember. He wants to do his magic, okay? Abracadabra, shte mitz achalta pilpel, tochal gam chamtzit. Nice one, Professor Pupik. Well done. Okay, kol hakavod. Okay. Right, so let's start with some concrete examples. F of x equal to x. Is that 1 to 1? Of course. Okay? If I put x 3, then y will be 6. If I put x equal minus 5, y will be minus 10. You can't have two values of x, separate values of x will give the same value of y. Okay? When do we have, can we think about y functions here? I'm moving away for a bit. Can we think about graphically, how can we think about one-to-one function, okay? A one-to-one function will be, let's say, something like this, where if you choose a certain value of y, any value of y, okay, it could be there, it could be this, any one value of y, fine, go to the graph and then cross it. If there's more than two x values, then it's not it's not one-to-one. So, for example, I'll choose this one here. Now, this is a certain y value. Then I go down. Okay, I go around here. Is there any more x's? I mean, this is obviously the x will turn that y. But if I'm going from here and I'm going horizontally, and basically that's what I'm going to do. I'm going to go horizontal from any line of the graph here. Horizontal. Any intersect horizontal line across the graph. If there is another point on the graph, okay, then there will be a different x. It's a bit difficult to see here. I'll show you with a function which is not one-to-one. This is one-to-one. That is one-to-one. Okay? Right? Let's think about a function that is not one-to-one. The easiest thing for me to think about is any kind of parabola. Because if I'm picking up a y value, let's say here, then I can see, if I do a horizontal line, I will cut the graph in two places. What does that mean? It means there are two values of x. Okay, let's say minus 5 and plus 5. Just making up numbers. They will give you the same value. So that's not one-to-one. Okay, hopefully that makes it a little bit easy to understand what is one-to-one, what not one-to-one from a graph perspective. Okay, so copy that if you want, and let's just move on. Okay. So, we've got this equation, f equal 2x. That is obviously a linear function, so it's going to be one-to-one. And we asked to find what's the inverse function. So there's two steps we got to do. Now, in the book, this book, and I think also in your textbook, they're doing the steps in different order than I do it. But it works out the same. I like it the way I do it, but I'll show you what they do in a second. So the first step is basically just to write, or before even the first step, just to write it, f of x equal to x, so you just write y equal to x, right? Just another way of writing f of x equal to x, okay? So an x value will give you a certain y value. Now, the first step really, as you can see, it says here, solve for x. Okay, no problem. So I'm going to write x equal y over 2. So that looks like a different function. Okay, it's a different function, y over 2. Okay? Now the second step, you see what it says here? Swap x and y. So I'm going to write, wherever there's x, I'm going to write a y. Wherever there's a y, I'll write the x. I'm going to write y equal x over 2. And that's it. Okay? So the inverse function is f minus 1 of x. The inverse function of x is x over 2. Okay? Now let me just try and explain before I see if it's correct. Okay, let's just see if it's correct. Let's just see if it's correct. So if I have f of x, okay, going from here to here, okay. So let's take a bunch of numbers. Let's take 1, okay. If I take 1 and I'm applying f of x, in other words, I'm doing 2 times x, so 2 times 1, it will give us a 2. So if I put 1 in here in f, it spits out a 2. Okay? That is if I do 2x. Let's go, in theory, if I put in the inverse function, which we decided is x divided by 2, if I put in a 2, it should bring me 1. Does it work? 2 divided by 2, 1. So it works, okay? Okay? Now let's try and understand what we've done here, okay? Function, a normal function, takes an x and turns it into a y. So it just doubles it. If I want to find the inverse function, then I need to put given a certain y, get that x back. And this is what I've done here. Okay? So by solving for x, I find the inverse mathematical relation between x and y. So if I put the same y that I had here too, I'll get my original x. Now, why did I have to swap the x and the y in the second step? Well, just because when we write the function, we always write it as y equals something. We never write the function as x equals something. So if I write x equals y over 2, that's not wrong, okay, but it's just not the way we're used to. Okay? We always have y equals something. So in this case, the number that I'm putting in is actually the y. So I'm going to swap the x and the y. I hope that kind of makes sense. Kind of, okay? Now, just a word about how they do it in the book. They do in the book in the reverse order. Same steps, but in reverse order. So the first thing they'll say, just like I did here, they'll say, okay, y equal to x. They start here. And now, they start with step 2. So they swap the values of x and y. So they're going to write x equal to y. So they did the swap first. And now, instead of solving for x, because we already swapped x and y, now we're solving for y. So they swapped x and y, and then because I wrote solve for x, but now x is y is x, they still solve for y. So y equal x over 2. But in both cases, as you can see, we get the same result. Okay? There's nothing wrong with each one of these methods. They're the same. I'm going to stop here. The video is getting longer. I'll do another video with a few more examples.